Okay, welcome back everyone. We're going to be doing the 2019 chemistry exam today. I might have to put this one over 2 days because I'll be quite busy. I'll see how we go. This exam is also a little bit of notoriety since it has a total of 240 marks. So we're going to have to be working overtime for this whole exam. I won't be able to do my usual stop and think. I think I'm going to have to just power through. So we're really going to have to try to save as much time as we can in every question. My booklet here, I have my calculator, and we're ready to go. So let's start. Boric acid, which is weak acid, was titrated with standardized sodium hydroxide. Would be most suitable to use in this titration. So since we're reacting weak acid with a strong base, our pH color range is probably going to be in the slightly basic or more basic. So probably 8 to 10, so C. I feel like 10 to 12 might be too much. Yeah, we'll do 8 to 10. The Harper process involves the following equilibrium equation. A number of, should we do 8 to 10 or 10 to 12? Phenolphthalein is 9 to 11, I think. I'm just thinking of 8 to 10. The Harper process involves the following. A number of clothes was set up containing the gases shown in the reaction below. Which of the above would equilibrium be established after a period of time? Nitrogen and hydrogen, yes. Nitrogen, no. Ammonia, yes. Hydrogen and ammonia, yes. So 1, 3, and 4 only. Nitrogen dioxide is formed when nitrogen monoxide undergoes oxidation as shown below. A change was imposed on an equilibrium mixture. The mixture returned to equilibrium and another change was imposed. The following graph shows the effects of the two changes. Identify the imposed change that best accounts for the shape of the graph. So the first change, we going backwards. The forwards is exothermic, so it's a reverse going to be endothermic. So we're going to have temperatures increased for the first one, and then the second change, the partial pressure of O2 is increased, the partial pressure of NO is decreased. Make sure we're going back. So we're going the endothermic direction, so we're increasing temperature, and then NO2 is decreased. What do the partial pressures of the three gases indicate? Relative proportions, present at equilibrium. There was initially no NO2 gas present in the system. If the NO2 gas reaches equilibrium first, that's definitely no. So it's also definitely no. But the O2 are producing at a faster rate than they are being formed. A faster rate than they are being formed. No, because the reaction rates would be the same. It would be A. Okay, corrosion of brass plumbing fixtures have been identified as a possible cause of the presence of lead in drinking water. Brass is an alloy of copper and zinc, but also contains lead to improve machinability. The corrosion of brass is a redox process with an electrochemical cell forming on the surface of the brass as illustrated below. Which of the following correctly identifies the anodic region, cathodic region, and direction of the electron flow? What the heck? Oh, okay. So here, that's -2. So star is being reduced, so this must be cathode. And here they are being oxidized, so this is anode. So anode is the trident thing. And it always goes anode to cathode. Cathode to anode. Anode to cathode. So going this way. Anode to cathode. Because cathode needs them to reduce. So yes. Not that. The overall equation of lead, what is the theoretical E naught of the overall pure PbO2 under standard conditions? So PbS is negative, so O2 CO2 gas plus H2O. 4 0.4. I'm looking at the right one. So PBS is negative 0.13, and water is 0.4 minus negative 0.53. Okay. The composition of brass. Oh wait, yes. I was wondering why there would be, because there's OH on the right, but there's only 2, but it's 2 times 2, which is 4. Okay. The composition of brass can be adjusted by adding various metals. The following would not undergo corrosion if added to brass. Would not undergo corrosion if added to brass. So zinc, lead, and copper. If we added silver, it would not. I think this would. Where's the highest one? Copper, probably. Yeah, copper. So anything above copper would not, and it's only silver Ag. Because nickel would and iron would. Yep. A distinguishing feature of strong acids is they produce high concentrations, contain loosely held, ionize rather than dissociate in water, have high acidity constants. This one. Because that's the, I'm pretty sure that's the Ka. Acidity constant, yep. Which of the following is an alpha amino acid? That's not. That's not. That's not. That also is not. Never mind, maybe it is this guy. I thought it had to be a hydrogen group coming off this carbon though. But that's an Se. But I guess not, because the others, they're coming off 2 carbons apart. 2 carbons, more than 2 carbons, and 2 carbons, so yeah. Hey, we're sure the statement is correct. Fluorine can be oxidized by potassium bromide. So fluorine can be oxidized. That is definitely not correct. Chlorine can be oxidized by potassium fluoride. Chlorine can be oxidized. And fluoride. Fluoride, yes. Wait. Potassium fluoride solution. No. Not by potassium iodide. That's not true. Chlorine can be reduced by potassium bromide. Clockwise. But not by potassium iodide. No. Bromine can be reduced by potassium iodide. Reduced by potassium iodide solution, but not by potassium chloride solution. Which is correct. Let's see, number C. Am I better C, right? Can be reduced by. Can be reduced by iodide, and bromine can be reduced by iodide, and it cannot be reduced by the potassium chloride solution. So D. Which of the following statements about catalysis, and the production of biodiesel is correct? Base catalysts generally have a high reaction rate, but unlike can cause which decreases the biodiesel yield. That's correct, I think. That's false. Base catalyst involves only one step, but involves many steps which turn as to the cost of the process. The iPad isn't charging. I don't think lipase is involved in any step. Since the acquisition method has high energy cost, that's incorrect. Yeah, bases have a high reaction rate and can cause saponification. The United has the integral panel on climate change, which of the following shows the production of a greenhouse gas? So methane, carbon dioxide, ozone. Water is a greenhouse gas, isn't it? N2O, dinitrogen oxide. Well, there's none that are all of them except for 5, so this one. Because 2 definitely needs to be it, so it's not that. And 3 definitely needs to be. And methane is 1, so yeah, C. One method of producing biodiesel is by trans-esterification reactions where triglycerides are converted to simple methyl esters. The biodiesel with fatty acid. Which of the following is a reactant of this trans-esterification reaction? Methyl esters. Biodiesel is a reactant. We'll just do that. So, oh no, that's the product. This, I believe. No, it's not that, because the O needs to be there. It's not that. It should be this, because it's a triglyceride. Simple methyl esters. We add an alcohol. We'll finish there. And then the OH will go on to end. And that becomes an ester. Yep, so ester link, so C. Which of the following properties exhibited by octanol is not related to the dispersion forces between the molecules? Melting point is, that is, solubility is a combustibility. Which of the following compounds will not exhibit geometric cis isomerism? Bute, difluoro-1-butene. So 1. I think it's will not exhibit difluoro. So F, F, and CC. That has to be H. So is it just A? What does 2 look like? Oh wait, F, 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 H, 3, 4. Cis trans. 1, 2, 4. Fluoro, H, H, CC. Am I stupid or like all of these won't? 1, 4, 2, 2. I feel like this is the only one that does. Then you have fluoro, fluoro, and you have H and H. So this is the only one that does. Will not exhibit geometry, but all of them won't except for D. Bute, difluoro-1-butene, 3, 4, 1, so H like that, 2, CH, is it just B because they're off the same? I have no idea. Do not exhibit geometric cis trans isomerism. I'm just gonna stick with A. I think there might be an error in this question. Which of the following is true statements about an aqueous solution of pH less than 0? 25 degrees is true. There are no aqueous ions present. The concentration is much greater. There are no H plus either as there are 4 molecules through the process of neutralization. So pH less than 0. That means that 10 to the 1 times the concentration of H minus must equal 10 to about 15 or 14. So there are not no OH. It can. We'll just be like this. Which of the following sets do all the bolded and underlined atoms have the same oxidation number? So that's just -2, that's 0. It's 2, so it's not that. The O2 there is going to have -1, the Cl is going to have -1, and the Mge is going to have -1. So 2, and it's not 1, so it has to be this. 3 plus 1 plus 1 plus 1. Fe here has -2, -3. Yep. Which of the following could not be a product when propane 1O is oxidized? So this is just this one, propane 1O. 1, 2, 3, 4. Oh wait, 1, 2, 3. OH. How are we getting CO2? Oh, because it could be used as a fuel, right? And you can't get that O to be here. Okay, so it's D. Because you can get B and C from just normal oxidation, and then A would be a combustion as opposed to oxidation. Oh god. A group of year 12 chemistry students wanted to know whether ocean acidity increases the rate at which seashells dissolve. They went to a beach to collect seawater and seashells. In their school laboratory, they crushed the seashells and added 2 grams of the resulting powder to 5 clean 250 milliliters, which were placed on top of its own electrolyte balance. They split the seawater into 5 portions and bubbled carbon dioxide gas into 4 of the portions for different amount of times. This gave the students natural seawater plus 4 seawater samples of different pH, the various pH 150 milliliter portions, were then added to the beakers with the weight which beacon its contents be recorded at time intervals. The sea chart pattern will dissolve fastest in the most acidic seawater. And carbon dioxide changes pH more visual so probably A. Because we have an independent variable and then the dependent variable. And it increases the rate. Which of the following pairs of statements on the validity and reliability is correct? pH, increasing ocean acidity, is reliable because the trials were performed in a laboratory. That's not necessarily true. D. Because it's valid, it's suddenly valid. 5, but it is, yes, reliability could be improved. Like most products are each different. Which of the following reactions is/are likely to be occurring within the beakers during the investigation? So I think 1 works. CO2 aqueous. No. No. COH. Okay, well there's certainly no CaOH. So not 3, not 3. 1, 2. So is 4 likely to be occurring. Okay, apparently 2 is likely to be occurring. So B. Okay, which between each of the following pairs of substances can dispersion forces exist? The background just came in. Okay, which of the following is an isomer of pentanoic acid? So pentanoic acid is CH3, CH2, CH2, CH2COOH. So C5H57910 O2. 5. Okay. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. Oh. 1, 2, 3, 4, 5. 1, 2 oxygens. 2, 3, 4, 5, 7, 9, 10. Boom. That's that one. Make sure 1, 2, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Yep. CH2. That's 5, 10. Which of the following underlying species is acting as an acid? That one is accepting, so no. That is accepting, so no. That is accepting, so no. And then this is donating to the H2O, so yes. How many isomers does the compound C2H3Br3 have? C2. So I can have H, Br. So I can have 3 Brs, 3 Hs. Or I can have Br, H, Br. Because then if I swapped it for Br, H, Br, H, that's just the same as this one but flipped. And then if I put one again, I'm gonna have 3B on one side and then the other side. So it's only 2 isomers. So 1, yeah, 2. Okay. Dilute hydrochloric acid HCl is added to 3 labeled test tubes. Excess copper metal, Cu, is added to the first test tube. Copper oxide is added to the second, and excess copper carbonate is added to the third. Describe the contents of the first and second once any reactions are complete. CS S plus copper to like copper oxides. Let's do 2. Let's try to do this first. So CuO solid plus HCl aqueous. Make. Is it going to be 2 Cu? Oh, sorry. Is it going to be 2 CaCO2 plus H2O liquid? I think that'll be right. Not sure. Copper metal of HCl. So I'm going to produce gas, copper chloride, which is soluble. What's going to make soluble copper chloride? I assume, I'm not sure. I'm going to say green solution and its excess copper metal with pink salmon solid with pink salmon metal strip. Of the test tube. Are they going to be the same? Any reactions are complete. Does copper react with hydrogen? Oh wait, I can do this, I think. Okay, using my standard table. Okay, this will not, because I'm using my standard reduction table right now, and nothing would happen. Because H2 plus aqueous, I can't do clockwise in copper solids, so no reaction. No reaction. Therefore, pink salmon solid at bottom of test tube containing colorless solution. Colorless solution. And then for the second one, oxide, I'm going to assume that it makes the CuCl. So green solution with pink salmon solid or pink salmon metal. That's up here, metal. It's copper chloride base green, right? Yeah. Pink salmon metal at bottom of test tube. Okay, we still have like 200 marks to go, so we've got to keep going. If the test tubes 2 and 3 have been smudged, describe all observations that we use to distinguish between these test tubes and once any reactions are complete. Test tube 3 would produce colorless, odorless gas. Colorless, odorless gas. When HCl is added. Test tube 2 would not produce gas. And I only need to talk about the ones that would be used to distinguish. So I don't need to put anything else. Calcium hypochlorite, CaOCl, is used for the treatment of water in swimming pools and is sold as pool chlorine. Explain why a basic solution is produced when pool chlorine dissolves in the pool. Include an equation in your answer. Pool chlorine is dissolved into the pool. When dissolved, hypochlorite, the ions will dissociate. Into Ca plus OCl minus, and then let's see, so OCl minus aqueous plus H2O liquid become OClH, HOCl aqueous plus OH minus aqueous. OCl minus will hydrolyze with water to form form OH minus ions, therefore which will neutralize H3O plus. Therefore H3O plus concentration down as pH equals negative log 10 of the concentration plus pH increase. Oh wait, no, I don't need to write this. Therefore solution is basic. I need to which will neutralize, therefore basic solution. Dissociate and form OH minus ions, which will neutralize. Therefore basic solution. I'll say basic solution here. pH increase negative log 10. Maybe I'll write it here. H3O plus. When concentration decreases, pH increases. And then CaCO2 plus is neutral, as it will not hydrolyze with water, therefore not affect H3O plus concentration. Associate with hydrolyzed water to form that, which will neutralize that. Therefore basic solution, pH greater than 7. Okay, and then the equation is that for balance. I think I'll finish this question and then I'm going to need to go. A pool chemical is used to counteract the basicity of pool water. Is hydrochloric acid, so is pool acid. So I'm going to the pH of the pool and pool acid as a pool to illustrate your statement. So then HCl aqueous plus H2O liquid becomes H3O plus Cl minus. Yes, I think. pH will decrease. Cl added. Concentration of H3O plus increases. Wait, does this need to be an ionic equation? Maybe. I'll just do that. So H plus aqueous. Associated ionizes to H plus and Cl minus. H plus reacts with water, forming H3O plus. As pH equals negative log 10 of H3O plus, as H3O plus increase, pH will decrease. Pool chlorine and pool acid must be stored separately from each other because calcium hypochlorite can react explosively on contact with hydrochloric acid. The equation for this is given below. Sketch a clearly labeled diagram illustrating the reaction between the pool chlorine and pool acid. Okay, I don't have any values, so I'm just going to say enthalpy and progression of reaction. And let's see, can react explosively on contact with HCl. So it must have a small activation energy, and it's obviously exothermic. So here, let me go up to there, up to there, and then we'll go sharply down, maybe up to about there. So we'll call this delta H. Delta H is less than 0. And here will be our CaOCl2 plus HCl for HCl aqueous. And we can say that this is our activation energy. Energy EA. And at the bottom is CaCl plus, so CaCl2 aqueous plus 2H to a liquid plus 2Cl2 gas. Okay, so maybe 2 for the axes, 2 for, maybe 1 for shape of exothermic, and then labeling, and then products and reactants. Okay, pretty happy with that. Not sure if here donates, maybe I should use sponsored by donate to H plus with water. It donates its H2O forming water. Plus, therefore the concentration of that will increase. Okay, and then I'm happy with that. Okay, so I'm gonna take a break, gonna hop off for now, and then we're gonna come back and finish this exam later. I have a little bit of time, so we're just gonna continue from here. I only have like a few minutes, so we'll see what we can do. Alright. 3, 2, 1, boom. That was just a sync. Okay. Here, what was I up to? Did I do these? How do I answer these? Form, neutralize, excess. Should neutralize that. Counteract the basicity. Oh wait, it says to counteract. Donates its H plus, H minus from the H2O. From the H2O. Okay, so I'll get rid of all of this. Since it donates its proton to a hydroxide, plus H plus aqueous, and this will go to form H2O liquid. And this increases, therefore decreasing concentration OH minus. Okay, let's continue. I think I had to spend a bit of time on that, so I'm pretty happy with that. What is the oxidation number of chlorine in calcium hypochlorite? So this is 2 plus. So this here must be 1 minus. That's 2 minus, so that's plus 1. And then here, chlorine must be minus 1. Yes, okay. Chlorine gas is produced at oxidation of one of these, and the reduction of the other. Write the two half equations showing how chlorine gas is produced from both substances. So Cl2G has an oxidation number of 0. So oxidation is going to be the hydrochloric acid. So HCl aqueous 2 plus 2H2O form 2H3O aqueous plus Cl2 gas plus 2E minus. There you go. That's why it's oxidation. And reduction is the calcium hypochlorite, CaOCl, OCl2 in this reaction, the chlorine and the chloride from the hydrochloric acid are both converted to chlorine gas. 2 plus, I'm going to say, probably H plus, 4H plus, 4E minus, which produce 2Ca, 2 plus, plus 2H, I don't think this is right, guys. Chlorine from both substances. Oh wait, so this is probably just a CaCl. CaCl2 aqueous plus 2H2O liquid. This is a reduction half equation. In reaction, the chlorine and the chlorine from are both they're both converted to chlorine gas. How are they both converted to chlorine gas? Waters 2H2O I get rid of that. Just have 2H plus. So it needs to be 2H plus on the left. Ca 4E minus, yes. CaCl2. Aqueous plus 2Cl Cl2 gas plus 2H2O liquid. In this reaction, the chlorine and the chlorine from the hydrochloric are both converted to chlorine gas. But how? But how? If I do that, I can make that 4H plus plus 4E minus plus 2 Cl2 minus aqueous. Does that work out? Is that what they want? might be what they want. I think it might be. I'm gonna have to stick with it. Okay, I'm probably gonna have to hop off now again already. So I was only got 7 minutes. Unfortunately, I'm gonna have to leave. So yeah, goodbye again. Okay, welcome back everyone. I'm back. I just had dinner as well from my adventure, so we're gonna continue. Now I feel a bit cheaty, but I was thinking about this question while I was away, and what I was thinking about was that last time I've done something similar with a HCl being oxidized. I remembered that since these will fully dissociate, you only take the Cl. So I think that will fix some of my problems. So we're gonna continue the timer now. So let's continue. So I think what's gonna happen here is that all we're just gonna have 2Cl minus aqueous. It's gonna become Cl2 gas plus 2 electrons. I think that's a much nicer thing. And essentially what happens then is that we still have 2Cl after, which will remain because we have 4 here, and the 2 are going to combine with the Ca2 plus. So that's going to work. And then here, I realized that my charges aren't actually balanced. So 2E minus, there you go. That should be it. Okay. This is the one, okay, this is the exam where it has a lot of marks, so I'm going to move fast. So sulfuric acid is very useful chemical, produced multi-step process. That hydrogen sometimes mixed with water, it produces sulfuric acid. Combine these equations to produce an overall equation for the production of dihydrogen from sulfur dioxide. Oh wait, I have to put my timer on. Pause for a second. And we are back. Okay, combine these equations to produce an overall equation. Okay, so from SO2 you make SO3, and we need, so let's do SO2 gas 2. That produces 2 SO3, so maybe I'll just do that. Gas plus 2H2SO4, so I'll get rid of that 2, and then this produces H2SO7. I'm a bit confused. Combine these equations. Production of sulfate. Do I just go like this? So SO2 gas plus O2, make that. Then I mix it with this H2SO4, only half. So I'll do half of H2SO4. Make that. And then I just add water. Half of it. And this will produce 2H2SO4. So now I have to get these all balanced up. Start with that. Now I need 2 of these. Now I need 2 waters. And then this will make 4. I think. So let's see, sulfurs. I'm gonna have 2 of. So 4 sulfurs. 4, 6, plus 8 is 6 is 14, 16. 16 is good. And hydrogens, I have ATAR, yes. Okay, I think that's our equation. Complete the table for the advantages, disadvantages of using high temperatures and high pressures for the reaction represented by equation 2 above. Consider yield, rate, cost, and safety. High temperature. If we use a high temperature, then reaction rate, oops, wrong pen. Reaction rate increase. What disadvantages? What's my yield? At high temperatures, I'm going to go that way. So disadvantages, yield will decrease, cost will increase, and overall safety with high temperatures decrease. Safety decrease. And it just says to list. Okay. Let's see, if we use high pressure, then high pressure will definitely increase reaction rate. Increase the reaction rate. High pressure, cause that to go that way. Cause that to go that way. So high pressure will increase yield. So yield will increase. And then, but then cost and safety. So cost will increase and then safety will decrease. And listing the advantages using high safety. Okay. I think, is that all I have to do for 6 marks? I'm not sure. Oh, he's gonna keep going. Salver sand. I just read 56 pages in this exam. Oh my lord. Jesus. Is an organic molecule that contains the elements carbon, hydrogen, arsenic, chlorine, and nitrogen. It was one of the first drugs used in chemotherapy and used for treating sleeping sickness. The empirical formula of this compound can be determined in a series of analysis. One process involves the reaction of a known mass of salver sand with an excess strong acid to convert all the chlorine into aqueous chlorine ions. Describe the laboratory process in determining the mass of chlorine in the sample once it's been treated with the acid. You should reference any chemicals used and include a balance equation in your answer. Mass of chlorine. How am I going to determine the mass of chlorine? Excess strong acid to convert all the chlorine I'm kind of lost with this question. H2O2? How many mass of chlorine in a sample? How would you determine the mass of chlorine once it has been treated with the acid? Can I do like add sodium? Okay, what's gonna precipitate out? Okay, chlorides, insoluble, Ag. Okay. So add AgNO3 to the solution. Of chloride ions. Then it will be like AgNO3 aqueous plus Cl minus aqueous. It's going to become AgCl solid plus NO3 minus aqueous. Therefore, and then, so I say here to precipitate, precipitate out AgCl solid. Then evaporate all solution away. After length of time necessary for all AgCl to precipitate out of solution. Sorry, that was my timer for Duolingo. So then let AgCl solid dry, then weigh, and find the mass final AgCl. And then we can say maybe calculate moles. Using molar mass of AgCl. This is more of chloride ions. Therefore, mass of chlorine can be found. Yeah, so you can like precipitate it out, and you do dry and weigh it, and all of that. Okay. The results of these 5.22 gram samples determined they contained by mass, okay, uses information to calculate the empirical formula of Salvarsan showing all workings. So 32 carbon by mass. Let's do that. So what does it have? Carbon, hydrogen, arsenic, chlorine, nitrogen, oxygen. Carbon, hydrogen, so I just need oxygen. 1.78 divided by 5.22 times 100. I feel like they gave me too much information. 9% arsenic. Therefore, percentage of oxygen can be equal to 100 minus 32.83 minus 3.21 minus 34.09 minus 16.18 minus 6.38, 71%. I don't think this is going to work. 32.83 divided by 3.21, so 10. 34.09 is 10.6. Yeah, it's not going to work, so let's just do it this way. So mass of carbon is equal to 0.3283 times 5.22. 0.3283 times 5.22. 7137 grams. So then the number of carbon is going to be equal to 0.7137 all over 12.01. 12.01, which is 0.1427 moles. Mass of hydrogen equals 0.0321 times 5.22. So 0.0321 times 5.22. 0.1676 grams. So the number of hydrogen is 0.1676 all over 1.008, which is 676.08. It's equal to 0.1663 moles. Number of arsenic. Now arsenic is an element. And it was AS, right? Yeah, 74.92. So number of arsenic is going to be equal to 1.78 all over 74.92. 74.92 says 0.0238 moles. Number of chlorine Cl is 0.1618 times 5.22, which is 0.8446 moles. No, sorry, grams. So the number of chlorine is equal to 8446 over 35.45. 0.8446 times 35.45. 0.0238 moles. Nitrogen is 6.38%, so mass of nitrogen is equal to 0.0638 times 5.22. This is 0.3330 grams. So then bring this all the way back up. Number of nitrogen is equal to 0.333 all over 14.01, which is 0.0238 moles. 38 mole. And then mass of oxygen is equal to 5.22 minus 0.333 minus 0.8446 minus 0.1676 minus 0.1717 or 1.7137. 717. I think I'm missing one. Minus 1.78 for the arsenic. And this is equal to 3 minus 0.8446 minus 0.1676 minus 1.7137 minus 1.78. 0.381 grams. So number of oxygen is equal to 0.3811 over 16, which is equal to 0.0238 mole. Number of mole equal number of nitrogen equals number of arsenic.
We see if you can buy ticket to
For what, the fly? Yeah.
tonight.
Yeah.
After midnight, I think maybe they got discount.
Okay. Sorry, go back. My power just came in to tell me something. Okay. So arsenic and also equal to number of 9 is least. So let's say number of carbon over number of oxygen. 0.1427, 0.0238 is equal to 6, and then number of hydrogen over number of oxygen is equal to hydrogen is 0.1663, 38 is equal to 7. Therefore, empirical formula is going to be C6H7OCl O and ClAs. What the heck? That is crazy. Oxygen equals nitrogen equals chlorine. What? 0. Yep, looks good. 0.0338. Just make sure I did that right. Yeah. Okay, gotta move on. Solution contains silver cyanide. Is used to plate a key with silver. Show the cathode and the anode direction of electron flow, refraction of ion flow, polarity. Okay, so we're plating a key with silver. So this is the cathode. And then in an electrolytic cell, it's opposite of what it should be. So that's negative. This is going to be the anode. Okay, positive. Electron flow is going to be this way, anode to cathode. And then direction of ion flow. So cations go this way, and then anions go this way. So this would be Ag plus and then Cn minus. Yes, I think this is the way. A salt bridge is used in galvanic cells, but it's not required in electroplating cell. Explain this difference between the two cells. In galvanic cells, so a salt bridge completes the circuit by connecting the two half cells of a galvanic, allowing free movement of ions. Between the half cells in an electrolytic. The electroplating cell is an electrolytic cell which has both electrodes in the same cell, therefore does not require a bridge for free moving ions to travel between the electrodes, between the half cells to the electrodes. Therefore does not require a salt bridge. The same one cell electrodes okay. Continuing, use excerpts from material safety dash for silver shine. Explain why the process is taken as safety precaution during the electroplating process during silver cyanide. Okay, I need to get these up, so I'm going to pause the timer. Hopefully I can get these up pretty quickly. I don't have to make a cut. Material safety data sheet. Oh man, I hate when I have to do this. This happens a lot in physics as well. So chemistry. I'm only going to do 40 more minutes of this exam because I want to stop at 11 p.m. So additional past exams. And this is the 2019 one, so I need the examination. Let's go all the way down to 56 pages. So this is material safety data sheet. Yeah, I think I got it. It says here, contact with acids liberates hydrogen cyanide, a very toxic flammable gas or liquid. It may cause cardiac, may cause that. Okay, so when silver cyanide, so AgCN contacts acids, HCN a very toxic flammable gas or liquid is liberated, is produced, therefore keeping a pH of 8 ensures a basic environment basic environment surrounding a GCl, ensuring there is minimal or there is no acid potential or minimal for it to contact an acid. Basic, I'll say here, pH greater than 7. So just 3 other safety measures that should be taken during the electroplating and indicate how each addresses specific potential hazard to either the workers or the environment. So it may cause eye irritation, so wear safety glasses. So it may cause eye irritation if contacts eye. Let's see. It is cause skin irritation, so you wear a lab coat. A lab coat, AGCL, may cause skin irritation if contacted. And then, perform electroplating under a fume hood. So anything about the environment, handling storage. Can't really find anything, so I'm just going to continue. Perform electroplating under a fume hood or very well ventilated room. Let's see, inhaling may cause tract irritation. Inhaling, floating powdery particles of HCl may cause respiratory tract irritation. And can adverse central nervous system. Can damage central nervous system. Okay. For measuring a cylinder of that is added to a flask containing of cat that. Tell them the final pH of that. So let's see, number of H plus is going to be equal to the number of HNO3, which is going to be equal to the number of 0.034 times 0.114. That is 3.876 times 10 to the negative 3 moles. Then number of OH minus equals to number of Ca2 or CaOH2 is equal to 2 times 0.0445 times 0.0556. 6. Let's make sure everything is looking good. So 0.450556, so 4.9484 is 10 to the negative 3 mole. Maybe I'll just do here, maybe I'll just do the equation. Plus 2H and aqueous is going to equal, actually no, I don't need that. So then I can say N of OH minus greater than number of H plus. For number of hydroxides in excess equal to 4.9484 minus 3.876 times 10 to the negative 3. It doesn't say to include an equation, right? Yeah, okay. So then 4.9484 minus 3.876 times 10 to the power negative 3 is 1.0724 times 10 to the negative 3 mole. Therefore, I can do concentration of OH minus is going to be equal to 1.0724 times 10 to the negative 3 all over 0.034 plus 0.0445. So this is equal to answer 0.034, 0.0445, 1.366 times 10 to the negative 2. And we know that OH, this is probably where the last few marks are. So 14, so then H plus is going to be equal to 10 to the negative 14 all over 1.366 times 10 to the negative 2. 10 to the power negative 14.366 10 to the power negative 2, 7.321 10 to the negative 13. pH is negative log of log 10. 321 times 10 to the negative 13. Negative log 7.321 10 to the negative 13. Right, so I get pH is equal to 12.1. Now what's my POH? So log or negative log 1.366 10 to the negative 2. So 14 minus answer 12.1. Yep. Okay. Next, question 33. Organic molecules have a hydrocarbon skeleton and can contain functional groups that are responsible for the molecule's characteristic chemical properties. Write the structural formula. Write the structural formula of the organic product from the reaction, and writing the name of the organic product. Okay. C like that, and petoine. So we can see. So that's on the second one. So we can say CH3H, CH2, CH2, and then that's H. And then structural formula of organic product. This is going to be CH3, CH, BR. Oh, maybe I should just draw all the hydrogens. I'm going to draw all the hydrogens. Oh, that should have been 3 as well. So this is H, 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 H. So then 3, 4, 5. So then H, 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 H. So this is BR. This one's also BR. H, 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 H. And then the name of the organic compound is 2,3 dibromo pentane. Okay, ethanol. So we have 1, 2, OH, and then this is just H. It's probably KMNO4 of the organic compound. So this is going to be the carboxylic acid, OH. So this is going to be ethanoic acid because it's getting oxidized. Sorry, where's the H? Yep. So butanoic acid. So 1, 2, 3, 4. OH, and then H, and then with CO3, because then the okay, so what's going to happen is the H is going to dissociate. So organic product is just going to be C is going to be the carboxylate. So 4 OO minus. So butanoate. Butanoate. Product. Ooh, do I include the Na? Yes, Na plus that maybe. So I did say sodium butanoate. Like that. Nah, I don't think so. I'm just gonna leave it like that. Okay, consider a reaction between magnesium carbonate and dilute nitric acid. Following data was contained with excess was added to 5 grams of time. Volume of gas produced. Brother, piece of time. Draw a labeled graph and then some volume. So this has to be in minutes. And then volume of gas. Produced. And this is in milliliters. So going 1 to 6. So yeah, I can do every second. 2, 3, 4, 5, 6, and then up to 33. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So maybe I just do 4 per each. So I go 0, 4, 8, 12, 16, 20, 24, 28, 32, 36. Okay, so it's time 0, we are at 0. At 1 minute, we are at 12. At 2 minutes, we are at 18. So 16 and then halfway in between. 3 minutes, we're at 25. So each one of these by 1, 2, 3, 4, 5. So 4 divided by 5 is 0 0.8. 0 0.8, so that's 3, and then about a little bit past 1, right there. And then 5 we are at, or 4 we are at 32. 4 is 32, so there. And then 5 we're at 33, so right there. And then 6 we're also at 33. Graph of the data provided in the grid below. Explain the shape. So I have to connect these. Okay, let's connect these. Boom. Oh no, it should be probably like a 16. 2 is at 18. 3 is at 25. 4 is 32. Okay, so I'm just gonna do something like this. Let me just the marker there, so something like that. Okay. Oh, that is terribly drawn. Jesus Christ. Yikes. Probably did not choose the best scale for this, but it is what it is. So, say, I'm going to shape of the graph in A. So, steep initial gradient. Due to max concentration of reactants. Therefore, increased frequency of collisions. Therefore, increased reaction rate. Thus, fastest formation of products. As reaction progresses, concentration of reactants decreases. Therefore, frequency of collisions decrease. Therefore, my reaction rate will decrease. Thus, slowing formation of products. Hence, gradient gets flatter until reaction reaches completion. Completion of limits of reactant. Then no, because this isn't reversible. Yeah, okay, it's not reversible. Then no more reactant collisions. Therefore, no formation of products due to no reactions occurring. Therefore, zero gradient. reaction progresses. I'll just put in bracket here. Time progresses. Therefore, I'll do a gradient. Okay, sketch a line and graph to show the effects of conducting the same experiment at a high temperature. So this is like a dotted line. Oh, no, okay. Maybe I'll just do a dotted line though. So we go to a higher temperature, then our reaction rate would just be faster, but it would still only reach up to the maximum. So the increased temperature. I don't like this graph though, it's not the nicest. Seems like a very straight line. So here we go +6 and we go +7 and we go again +7. So it's very linear in that area, in that region at least. So it's not the easiest to graph. +6, +7, and +7, yeah. Well, can't really do much about it. Okay. Consider the following acid-base titration curves that is produced by the addition of sodium hydroxide to approximately 1 molar diprotic acid. Indicate whether the diprotic acid is most likely to be sulfuric acid or sulfurous acid by circling your choice below. Do I have to explain why? Sulfurous acid. Because it was sulfuric acid, the pH at equivalence points would be at 7. Sulfuric acid, pH at equivalence point would be 7. As strong base plus strong acid. Wait, what was this? Diprotic acid. pH at equivalence is basic. It's greater than 7, indicating weak acid. As salt produces basic. And then what's another reason? Okay, it's a weak acid. What's my second reason? Oh my god. pH at equivalence was. Okay, I'm gonna reword this. pH at equivalence point. Second equivalence point. Oh, I don't know the second reason. Oh, chat, I don't know why. Other than that, if it was sulfuric, it should be at a pH of 7. Can't think of it. Give 2 reasons for your answer. I can't think of one. Okay, I'm going to continue. Predict the effect, increase, decrease, or no change on the calculated concentration of the acid following 2 systematic errors and with current titration goes by choice. Only rinsing the pipette with distilled water before use. So then it will dilute the NaOH. Therefore require increased titer. So it would increase the concentration for mole of acid would increase, therefore concentration would increase. Use a pH with an indicator of an endpoint of 4.5. And it would decrease, would not allow all, no, would end titration too early. Therefore, the titer amount decreases. Therefore, the moles of acid would also decrease. So then the concentration would decrease. Oh wait, this is the pipette. Pipette used for the diprotic acid. So dilute the NaOH, dilute the acid. Therefore, you decrease the titer. Mole of acid less than, so calculated will be less than mole of acid. Sure. Concentration of acid. Therefore require less titer. This will actually also decrease. 4.5. Only rinsing the pipette with distilled water before use. So yeah, you would dilute the acid, which then would require less titer. So when you think there's less acid, there is, so the concentration would decrease. Dilute the acid. Yes, okay, state one reason why these errors are classified as systematic rather than an error. Will occur, these errors will occur to every trial and sway data and skew data in one consistent direction. Somewhat with consistent extents, consistent effect on data. So then skew data every trial. End of section 2. Okay, I have extended answer. 109 marks to get through. The ideal pH of human blood is 7.4. The pH of a person's blood varies too much from this value. A serious condition can develop. pH is too low, it is called acidosis. pH is too high, it's called alkalosis. Death may occur. Jesus Christ, okay. One buffer system for maintaining acid-base balance in the blood is the carbonic acid hydrogen carbonate buffer. During exercise, the muscles need more oxygen to produce energy. They produce carbon dioxide and hydronium ions, which move from the muscles to the blood. The relevant equilibrium equations for the carbonic acid and hydrogen carbonate buffer system are shown. Identify the two conjugate base and clearly which is the acid and which is the base. So conjugate acid 1. actually I'll say here. So acid is H3O plus. Base would be conjugate acid is H3O1. You're gonna say like pair 1. H3O plus. And then conjugate base, which is H2O liquid. And then for pair 2, conjugate acid is H2CO3. And then conjugate base is HCO3 minus, because that's accepting. Write the equilibrium constant expression for equation 1. So Kc equals, it's going to be H2CO3 all over H3O plus and then HCO3 minus. H3O plus HCO3 minus. Carbonic acid further reacts to form water and carbon dioxide as shown in equation 2. Combine equations 1 and 2 to create an over equation that shows a relationship between HC3 minus aqueous and CO2 aqueous. So H3O plus H3O equal water. So then HCO3 minus aqueous plus H3O plus. Just gonna do that. And all I'm gonna do is I'm gonna sub in H2O and CO2 for H2CO3. So I'm gonna get 2 H2Os. So 2 H2O. This is what I did for the early one. I don't think I explained it very well though. And aqueous like that. And that looks good to me. Identify the effect on the blood's pH when each of the following components are removed. If carbon dioxide ions are removed, carbon dioxide ions and H2CO3 is going to go to the right. It's going to get removed. So it's going to decrease pH. I think. So carbon dioxide is removed. And this goes down. Then this goes like that. Less H2CO3. So then we're going to go across. So then yeah, H2 goes down. Okay. The next one, so pH will decrease. Hydrogen carbonate ions are removed. So if hydrogen carbonate ions are removed, oh wait, no, hold on, we're getting rid of hydrogen. We're getting rid of the H3O plus, so it's actually going to increase. And then hydrogen carbonate ions go to the left. So then H3O plus is going to increase, so pH will decrease. The buffering capacity of carbonic acid is greatest when the pH is between 5 and 1. State 2 conditions in terms of concentration that are necessary for this buffering capacity to be optimal. So I'm going to say similar, relative concentrations of, or similar or equal, so equal, or similar concentrations of hydrogen carbonate and so HCO3 minus aqueous and H2 CO3 that's just aqueous, so similar relative, and then high absolute concentrations again HCO3 minus and H2CO3. When the pH is too high, the kidneys can remove from the blood. You shall demonstrate that kidneys action to help prevent excessive high pH. So is this just as H3O plus increase, or is blood too high? pH increase means remove hydrogen carbonate ions from the blood. Oh wait, no, hold on. Okay, so this, the hydrogen carbonate is what I need to go out. So as HCO3 minus decreases. Equation 1 shifts to the left. Equation 1 shifts to the left to attempt to partially replace lost HCO3 minus. Therefore, concentration of H3O plus will increase, which can react with OH minus, therefore lower the concentration of that. Neutralizing it. Therefore, less excess OH minus, therefore preventing excessive high blood pH. As H3 plus increase. I'll say here which decrease pH. So increase pH. Wait. Less excess. So yeah, decrease pH. Preventing excessively high as pH equals negative log 10 of H3O plus. H3O plus will increase. Okay, when inhaling, oxygen is taken into lungs and transferred to the blood, while exhaling, carbon dioxide is expelled. During hyperventilation, very rapid and deep breathing, more carbon dioxide is being expelled from the body than it can produce. This upsets the oxygen-carbon dioxide balance and causes dizziness and fainting. The hyperventilating results in lowering the carbon dioxide concentration in the blood, which can affect the pH of the blood. The equation shown below illustrates the formation of hydronium ions within the blood system. A first aid treatment for hyperventilation is the paper bag treatment, whereby the patient breathes into a paper bag and so breathes back into the expelled breath, which is a high concentration of CO2. See the effect on the pH balance of spywhite is an effective treatment for hyperventilation. Okay, so paper bag treatment. This person breathing back in, expelled CO2. CO2 gas. Therefore, and then CO2 gas will do this. Aqueous. Therefore, the concentration of CO2 aqueous will increase. As that increases, then pH of the blood. Then as CO2 aqueous increases, above equation shifts to right. Shifts to right. Oxygen carbon dioxide balance. Above equation shifts to right, therefore increasing the H3O plus concentration. Hence pH will drop. Is an effective treatment for hyperventilation. As it prevents excess carbon dioxide being expelled. Or can you say like it recycles? As it brings back expelled excess CO2. Thus, bringing back the balance, thus rebalancing O2 CO2 concentration in blood. Concentration in blood. Preventing CO2 aqueous decrease. Preventing decreasing that. pH. Another contributor to potential imbalance in blood pH is the formation of lactic acid. The chemical name for lactic acid is 2-hydroxypropanoic acid. Draw the structure for lactic acid with all its functional groups circled and labeled. So propanoic acid, and then I want a hydroxy, so OH, 2-hydroxy. So then the rest of this should just be H. And this bit is the carboxylic acid. And this is the alcohol. Hydroxyl group. Okay. It's 11:07, so I'm going to stop it here. Pause the timer. So we have a minute. I mean, not a minute. If we had a minute left, we'd be dead. We have an hour and 7 minutes left. And we are on page 31. And there is 47. So we have 17 pages left to go and I have an hour remaining. So I have to be 4 minutes a page. Yikes, okay. We'll see how we go with that. So yeah. Alright then. I'm gonna stop recording here. Goodbye. I'll come back tomorrow. Welcome back, guys. So we're gonna be continuing from here. Let's go. Let's check this one. 2-hydroxypropanoic acid. So propan is 3, 2-hydroxy-OH, and then propanoic acid, OH. Yep. Okay, detergents and soaps are both used as cleaning agents. The general structure of a detergent is given below. Explain how detergents, blah blah blah. Okay, so we can have, so CH3, CH2, 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 H2, CH2. I think it's going to be 8 at least. It's 8 carbons, so I'll do 9. There's my benzene. SO minus. And here I'll do the H plus. Delta positive. Ion dipole. Forces, and here. Wait, what? Brother. I have to. Okay, I'm gonna pause the timer. Because that's not fair. I'm gonna redraw what I just did. CH2. 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. O minus. Ion dipole forces. Okay, up to here. I'm gonna continue. And I'm gonna have some grease molecule. And like some grease molecule. And it's like CH, H2, CH, CH2. And like OC, CH2, I don't know, say 8 and CH3. OOC, CH2, 8, CH3, OOC, CH2, 8, CH3. And I'll say that these are dispersion forces. Okay, so then say the detergent. And this is the non-polar tail. Hydrophobic non-polar tail. Hydrocarbon tail. And this is the charged polar head. Charged hydrophilic head. So detergent. Have a charged head and a non-polar tail. Non-polar tail will create dispersion forces with the, what do you call it, the grease molecules. That are stronger than grease to grease. The non-polar interactions, therefore we'll pull them from the surface. Surface of a, what do I say? So pull them from the surface and form my cells. A structure with non grease molecule and spherical structure of grease molecule and non-polar tail on the inside. Surrounded, what's that here? Grease molecule surrounded by. Come on. Non-polar tail on the inside of the sphere and charged detergent heads on the outside. The charged heads then form, oh god, ion dipole forces with water, attractive, which will carry my cell away. As the water flows past. And that is therefore removing grease from the surface. Carry the micelle away from the water. Detergents are considered to be more versatile cleaners than soap, explaining why soaps are generally less effective than detergents as cleaning agents in hard water. Okay. Soaps have active ions. Will form precipitates when reacting maybe I should say, okay, hold on. I'm gonna say that hard water. I'm gonna say this first. Hard water is water with high concentration of mineral ions, such as Ca2 plus and Mg2 plus. So this goes first. And I'll react with Ca2 plus, G2 plus, moving them from solution. Not allowing them to complete or to do the cleaning action. Detergents, surfactant ions, do not precipitate out of solution. when reacting with Ca2 plus or Mg2 plus, therefore can continue to do the cleaning action, continue to perform cleaning action when soaps cannot. Action soaps cannot, therefore detergents more effective, soaps less effective. Include a relevant equation in my answer. Oh god. Let's say CH3 and CH2 8COO minus, and I call this a soap. COO minus aqueous 2, we say this is a soap, plus Mg2 plus aqueous will create CH3 CH2, oh no, actually no, I can do it that way. CH8 COO2 and then Mg, and this will be a solid soap plus mineral ion and then this is for precipitate. I think that's all good. Okay. 34 alkanes can also form soaps. Draw a structural diagram for the soap ion using the incomplete structure below. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. There's 17. Wait, hold on. Quick pause. I need to put on my timer. I should move these. Quick pause. Yeah, back. Okay. So this is 17. So I need to do say O minus. And I need 31 hydrogens. And I have 16 carbons to put them on. So I should have equals 30, and then 3 at the end, so 33. But I only have 31 hydrogen. I think I remember this question somewhere. I think you need to put like 2 alkene bonds somewhere. Yeah, alkenes can also form soaps. So you can just, I assume, put them anywhere. So now we go on this boring mission to fill this all out. H, 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 H. This will be 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. One only needs to be one alkene. 30, 31. And now there's 16 times 2 minus 2 plus 1, 31. Yep. And you just put the alkene anywhere. Write an equation showing the formation of this soap from a fat triglyceride shown below. So then now I just need the 3 NaOH aqueous. So this will form the 3 C17 H31 COO minus aqueous plus 3 Na plus aqueous plus a glycerol, so H2C CH H2C, OH, and OH. Formation of soap is both an endothermic and equilibrium equation. Predict and explain the conditions that result in the highest yield of soap in the shortest time. As temp increase, velocity of particles, average kinetic energy increase, therefore velocity of particles increase, therefore more frequent collisions, therefore reaction rate will increase. Also, as average kinetic energy increase, proportion of particles with minimum activation energy will increase, therefore greater proportion of successful reactions. Therefore reaction rate will also increase then. And then we can say as temp increase by LCP endothermic reaction will be favored. Therefore, formation of soap favored. As increased products favored as it is endothermic. Products increase, therefore yield will increase. Not concentration of yield, just yield will increase. And then temperature increase, therefore as RR and yield go up as temp go up. High temp will be used to maximize highest yield in shortest time. Is that economic? No. And then we can maybe say addition of catalyst. Addition of catalyst will introduce alternative reaction pathway. With lower EA, therefore increased proportion of reactants with minimal activation energy, therefore increase RR, therefore form soap in presence of catalyst. And then we can also talk about just the concentration. Concentration of reactants increase. We can say that frequency of collisions increase. Therefore, reaction rate will increase for shortest amount of time. Catalyst to minimize time. Therefore, use high concentrations of triglycerides, of fats, and OH, or other reactants. To minimize formation time. Okay. Also as the amount of yield increase, final amount of circle increase. Okay, let's go. Polymethyl methacrylate and polycarbonate are two polymers that are used as alternatives to glass. Polymethyl methacrylate is more commonly known as perspex or plexiglass and is an addition polymer, while polycarbonate is thermocondensation polymer. Both polymers are transparent in visible light. Other properties are listed below. Following use alternative glass, found which before justifies by comparing the effect of two relevant properties are listed for both polymers. Skylight. So probably you want to use the polymethacrylate for skylight because it has more UV resistance. So I say polymethyl methacrylate. Methacrylate. Polymethyl. What if I just say that this is PMMC? So PMMC has better UV resistance. UV resistance than polycarbonate. So we'll reduce risk of health risks. Like skin cancer. And what's another one? It's lightweight. And PMMC is lightweight. So won't create significant structural stress. Significant structural stress on the house or car the skylight is in. Okay, safety glasses. Probably want polycarbonate. Polycarbonate. It has moderate chemical resistance compared to PMC's only low. Polycarbonate has moderate chemical resistance better than PMMC's low resistance. Also has better impact. Also has high impact strength compared to PMCs. High impact resistance. Compared to PMMC's low impact resistance. Come on. Okay, the monomer methacrylate can be found or can be formed from the esterification of methanol and methacrylic acid. The structure formula of methacrylate shown below. For the esterification of methanol and methacrylic acid, show the full structural formula of each species in the equation. So let's see, methanol is just going to be COH, O, and we can say H here. H is plus 2-methyl propentanoic acid. So I'll do it like this. 1, 2, 3. Propentanoic. So that's going to be COOH. And then 2-methyl. How am I going to have a methyl group? Two-methyl propentanoic acid. OH. What? Is it just something like this? Maybe? No, then that's not propanoic. Prop-2-anoic acid. Okay, so here's the bond. So yes, the bond's gonna be here and here. CO. What? Oxalic acid. Oh wait, not methanoic acid. That was what was confusing me. There we go. It's gonna be like that. And then 3, 4. I have no idea how this is going to work. So this is CCC and COOH. Methyl OOH 2 methyl, 1, 2. So then this would be H2O liquid plus CH O C double bond C CH H. I can go at the bottom. Come on. O H. And then the C has like that. C H. So something like that. Aqueous. This is aqueous. H3 to C corresponding to COO. I think that's correct. Okay. Methylcrylate can undergo addition, polymerization to form polymethylcrylate. Draw sections of the polymethylcrylate. Okay, so let's see if I do my C. My left hand is just going to be H, and then this one's going to have CH3, and then this is C double bond O, C O double bond. Wait, no, do it the other way. Double bond O O CH3. Okay, and I need to show at least 3 repeating units. So 1, 2, 3, 4, 5, 6. Like that. So H, CH3, C, O. Bro, I can barely fit this. H3, CH3, C, O, O, CH3, CH3, C, O, O, CH3, COOCH2. Okay. One method for the production of methylcrylate acid is by the following oxidation. So just an assumption that was made regarding the moles ratio of the product reacting for the reaction, and then determine the mass of the methyl. 1.5 tons. According to moles ratio. Would just be the number of C4H8O equal to 2 number of C4H6O2. Just because there's 2 oxygens there. And so the mass of the methyl ions required to produce. The efficiency of this oxidation is 65%. No, would it be? It's just 1, right? Methylpropanol. 2, 3. C, H, and then it becomes an O pretty much. And this is just plus Cr2. No, it should just be like that as equal. So calculate 1.5 tons of the methylcrylate acid. So mass of C4H6. 4 times 12.01 plus 6 times 1.00 8 plus 2 times 16. So then oxidation is always just one molecule gets oxidized to another. Times 16 is 86.088 grams per mole. Therefore, number of C4H6O2 is equal to 1.5 tons, so 1.5, not 5, times 10 to the power 6, all over 86.088, 2, answers 17424.03 moles. H8O theoretical is equal to 17424.03 moles. Over C4H8O with yield can be equal to 17424.03 or 0.65. 17424.03 divided by 0.65 is 26806.2 moles. So then the number of, mass of C4H6O, H8O is equal to 4 times 12.01 plus 8 times 1.008 plus 16. 1.18 times 1.08 plus 16. 72.104 grams per mole. Mass of C4H8O is equal to 72.104 plus 2, no, times 26806.2 times 26806.2. 1.93 times 10 to the 1, 2, 3, 4, 5, 6. 6 grams. That's on 2-methylpropane 2-anoic acid. 2. I don't know what this propane 2-anoic acid is. Okay, whatever. Polycarbonate is a condensation for which the byproduct is hydrogen chloride instead of water. The monomers are shown below. WACE is classified as an addition polymer, while polycarbonate is classified as a condensation polymer. Polymethyl methacrylate is formed from the breaking of 2 and doesn't produce any extra species. Polymerization. And then polycarbonate is formed from the reaction and linking of two reactive functional groups and eliminates hydrogen chloride, byproduct hydrogen chloride. This eliminates HCl as a byproduct of polymerization. Herbicides are chemicals that kill plants, including weeds. The label of commercially available herbicide concentration is shown below. A chemist was given a refined solution of sodium chloride and acetic acid. Sodium chloride was found to be consistent with tolerance of plus minus 5%. Perform a series of titrations, preparing by piping fire into concentrate, which is made up to mark distilled water. Of 20 milliliter samples, a few drops of rush titration for shown below. So 20.75 minus 1.28 is 19.47. 40.19 minus 20.75 is 19.44. 21.82 minus 1.48 is 20.34. Then 41.21 minus 21.82 is 19.39. So we only use 1, 2, and 4 as our concordant. And 4 plus 19.39 divided by 3, 19.43 will be our average titer. Identify what solutions each be rinsed prior to these titrations. The 5 millimeter pipette is herbicide solution. The 20 milliliter pipette is made of the diluted, say here, concentrated, diluted herbicide solution. And then the volumetric flask is distilled water. Okay, demonstrate whether or not the experimentally determined values of the ethanoic acid concentrations matches the value given on the herbicide label, bearing in mind that difference is considered acceptable. Okay, so let's see, number of NaOH is equal to NaOH is equal to 0.01943 times 0.0947, which is equal to 0.943 times 0.0947, 1.84 times 10 to the negative 3 moles. So the number of CH3COOH and 20 milliliter dilute is equal to 1.84 times 10 to the negative 3 moles. So the concentration of CH3 COOH dilute equal to 1.84 times 10 to the negative 3 all over 0.02. 0.02 is equal to 0.092 moles diluted by factor. It was 5 and 250, right? So 250 over 5 equals 50. Therefore, the amount of CH3 COOH concentrated equals 0.092 times 50. 2 times 50 is 4.6 moles per molar. Grams per liter. Therefore, and then we'll say mass of CH3COOH is equal to 2 times 12.01 plus 4 times 1.008 plus 2 times 16. 1 plus 4 times 1.08 is 2 times 16 is 60.052 grams per mole. Then assume 1 liter, therefore a number of CH3COOH is going to be equal to 4.6 moles. Therefore mass of CH3COOH 1 liter is equal to 4.6 times 60.052. 4 point, oh my god. Calculated error, so 276.24. Let's say 276 grams. 276 divided by 295. Times 100 is equal to, actually I'll do the full, I'll give it to a few more decimal places, 0.24 grams, 24 times 100 times 100 equals 295 times 100 is 295, right? Yeah. It's equal to 93.6%. Therefore, minus 7 point. So 1 minus 93.6 is 6.4% from advertised. Therefore, does not match give value given on label. Value given on label. 0.095 times 295. Yep. Okay, 42. A chemist was developing a new method for extracting lithium metal from ores rich in the mineral. Tight. The procedure was given as follows: crushing granule, which will dissolve lithium carbonate. Step 2, performed by chemist. 5 liters of sulfuric acid was in excess. Was used to crush a ground sample. 11 liters analyzed, found to contain sulfate ions and hydrogen ions from sulfuric acid, and the ions stated in equation below. Sulfate ions and hydrogen ions. Chemist tried to remove the rubidium and from cooling solution 5 so as to precipitate them with rubidium and alum. Equation is shown below. Chemists found that while all the Rb plus, there was a considerable quantity of Al ions to dissolve. Calculated concentration in grams per liter. Appropriate numbers of significant figures. 5 liters of leach solution. Concentration. Okay, so then let's see. Number of concentration of Al3 plus equal to 1.86 grams all over Al is 26.98. I'm going to make these all into molar concentrations. 0.06894 and then Rb plus, which is equal to 1.3, and then Rb is 85.47. 1.3 by the 85.47, 0.01521. Number significant figures. H2. Sulfuric acid was in excess, so I don't have to worry about that. Therefore, 5 liters. Number of Al3 plus is equal to 0.06894 times 5. 0.3447 moles. And the number of Rb plus is equal to 0. 0. Oh my god. 1521 times 5 is 0.07605 moles. So the number of Al3 plus excess will be equal to number of 0.3447 minus 0.0706 or 605. So 605 447 0.3447 minus the answer is 0.26865 moles. So the mass of Al3 plus is going to be equal to 0.26865 times 26.98 times 26.98, 2482 grams. So then the concentration of Al3 plus left over remaining is equal to 7.2482 all over 5. 7.2482 divided by 5, 1.45 grams per liter. 6, yep. Okay. To remove the remaining Al2 plus the solution, it comes out 2.6 liters of that. The result being the precipitation of potassium alum, as shown in the equation below. The sulfate ions, okay, was the sufficient adder to precipitate all in the leach solution, justified as irrelevant. So the number of, say, Al3 plus is equal to, it was 0.26865 65 moles. Number of K plus required is equal to 0.26865 moles. Number of K plus actual is 2.63 times 0.055 0.14465 moles. K plus is less than actual, less than number of K plus required. Therefore, number of K plus is limiting. Therefore, it was not sufficient to precipitate. To precipitate all Al3 plus ions. $44, $45, $46, $47. Okay, we might make it. The final purification step is removal of iron from the leach solution. To do this, the chemist uses a suitable oxidant to convert order to iron 3. There is additive to all the ion oxidants. Precipitate the aluminum from earlier removed by filtration. Write a balance equation to show the conversion of F2. So let's see, oxidation is going to be Fe2 plus to Fe3 plus an electron. So then reduction is H2O2. Let's see, H2O2. O2 plus 2H plus 2E minus 2H2O. Okay, so then full equation. Let's do with my H pluses. I'm gonna have just 2 on the left and 0. And then for water, I'm gonna have 0 and then just 2 on the right. Okay. So we have Fe2 plus aqueous plus H2O2 aqueous plus 2H plus aqueous. It's going to go into, sorry, there should be 2, like 2 Fe3 plus aqueous plus 2 H2O liquids. Same food. 2. The elite solution now free from rubidium aluminum was heated and evaporated with dryness yielding a lithium-rich residue. The residue was further treated to produce a lithium carbonate suitable for lithium aluminum covered. In theoretical amount that should be recovered using concentrations on page 42. So Li plus is 2.13, 2.13. So then number of, let's say concentration of lithium. 6.94. So 1.23 over 6.94 is 1.23, right? 2.13. This is why we check 2.13. Zero 0.3069 moles. So the number of Li plus is going to equal 0.3069 times 5. Right, 3069 times 5, which is 1.5345 moles. Now the number of lithium carbonate, which is Li2CO3. CO3 is going to be equal to theoretical is equal to half number of lithium plus ions, divided by 2, 0.76725 moles. Mass of lithium 2CO3 is going to be equal to 2 times 6.94 plus 12.01 plus 3 times 16. 94 plus 12.01 plus 3 times 16, which is 73.89 grams per mole. Number of lithium 2CO3 actual equal to 467 all over 73.89. 9 is 0.6320 moles. And for percentage yield equal to 0.632 all over 0.76725. 5 times 100. 0.632, 0.76725 times 100. 82.4%. 9 minutes. When insects touch a spider's section, they become stuck and therefore easy prey. Glue-like substance produced by the spider's fiber consists of water, protein, and exhaust and polar carbon compounds. Small section lists the names of the amino acids in order which they were drawn in the section. Do not use abbreviations. So the first one is alanine, I think. So let's see, that is just alanine. Alanine. Next one goes up to here. That is just glycine. Next one is up to here. Carbon thing. What is that one? Pentagon. Is that proline? Nothing else proline. This one is, sorry, let's make it here. This one again is glycine. What's the name of the amino acid? And the last one is CH. Theramine, I think. CHREONINE. Circle 1 peptide bond. I'll go with this one. There you go. What's the difference between primary structure and secondary structure of a protein? Primary structure is the amino acids and the sequence, and the order is the type. And order of amino acids in the chain, polypeptide chain. Secondary structure, I'll say slash protein. It refers to H bonds between or within protein chains, which make alpha helix or beta pleated structures. Splitting with water, ionic salts and polycarbonate compounds dissolve. The proteins do not dissolve and remain a substrate formation, so it happens well. They dissolve in water, but the proteins do not. Okay, what if I don't? Wait, is this the final question? Okay. You wash the water, the ionic salts and the polycarbon compounds dissolve. Proteins do not dissolve and remain on the silk strand. Ionic salts. Proteins do not dissolve. Fine, sure. Polycarbon compounds dissolve. Let's show you answer of the label diagram. Water is a polar solvent. Carbon compounds will form strong attractive forces to water, and I say here stronger than those that hold. Rewrite this. So the formation of dipole forces between water and polar carbon compounds release enough energy to overcome the PCC bonds and water, attractive bonds. Therefore, will readily dissolve in water. Proteins are held together by stronger hydrogen bonds. But proteins do not. Polar, then the polar H bond, dipole, and dispersion, and PCC, therefore the energy released between bonds forming of water between water become PCC dipole. Bond. Between the water, uniform between water and PCC cannot overcome the PCC sum of internuclear forces. Oh, we know proteins. Carbons with the aid of a label diagram. How am I gonna draw the compounds? Polar. Plus. And I have something here, and like this region is S minus, S plus. This is dipole. I don't think that's it, chat. This is my polar carbon compound. Okay, that was time. I know I'm definitely not getting any marks for a label diagram at the bottom there. I'm not even sure if I explained it well enough, but wow. I'm surprised we even managed to finish the exam. Oh, with no time remaining. Yeah. Oh, gotta mark this now. It's gonna be a long day of marking. I'll see you guys later. I've just marked. I've did this exam over 2 days, and then I marked it on the 3rd day because I've been really busy. We actually got a really high score, crazy improvement of 93.7%. Now, in the summary examination notes, it actually says that everyone would have got +5 marks because this exam was actually deemed to be too long and too difficult, so they boosted everyone's marks up by a little bit. So with these 5 extra marks, you can see how I decided to spread them across. I gave 1 to section 1, and then I tried to spread it across evenly, and then 2 to section 2, and then 2 to section 3. Without the extra marks, I would have got 91.3%, so still actually would have improved. It definitely would have got boosted up a decent amount with these marks. So yeah, 93.7%. Really happy with that. We're gonna go through the exam now. I feel like there might be a lot to go through. Multiple choice is all correct except for question 15, the one with the compounds and the isomerism. I think it's because so like this is A, right? So these fluorines, they can be cis or trans. And then C was 1, 2. So then I move you down a bit. Oh, okay. I'll just do B again. I mean C again. So C would be look like 1, look like that. And then it's these carbons that can be cis trans. And then for D, which was 1, the same thing actually. And then F and F. Again, the carbons and the hydrogens could have been cis trans. However, for B, since the F's are on the same side, so like that, so it's F and F, and then this carbon has a C and a H. There's not the same species across the double bond, so it can't exhibit geometric isomerism. So that was what we got wrong. The answer was B. Everything else was correct. So section, I'm going to be trying to move fast just to get this over with. So for question 26, what happened was, because number 2, it was excess copper oxide. Copper oxide in the formula data sheet is actually black, not pink salmon. So I lost a mark there. Let's make this red. For this question, it gave the ionic equation. So like it didn't have the aqueous ion, but I'm not exactly sure because it doesn't say a ionic in the question. It's just a balanced equation. So I suppose, I think this happened last exam too, where I should have done an ionic equation, but I did the full molecular one. But it doesn't say to do ionic, so I gave myself 3 marks. And then I said this last exam too, but I'm gonna try and remember to do ionic equations from now on, even when it doesn't ask me to. And then here you have to talk about the color of the solids. So I got a mark for talking about the gases, but yeah, you have to talk about test tube 3 would have a green solid, while test tube 2 would have a black solid. Test tube 3 was excess copper carbonate. Oh wait, no, that's because oh yeah, copper 2 carbonate is also green. Yep. So yeah. So here I got 4 marks. Excess due to hydrolysis, and then 2 marks for the equation. pH will decrease, and then equation. You could have also done like OCl minus reacting with H plus, or you could have done hydronium with OH. There were a few alternative equations you could have done there. That was good. This was also, this was nearly good. Correct. This oxidation was correct, so I'm glad I remember that while I was out. But this one, I think I must have been trying to do this with 2 CaOCl, and then I left the 2 there. So obviously I didn't get a mark for balancing. But I gave myself 1 mark here. You got 1 mark for having the correct equations in oxidation and reduction, like identifying which is which. So I gave myself 1 mark, 2 marks here for that, and then 1 mark here for my correct reactants and products. I just didn't balance correctly. Moving along. For this one, I should have crossed this out, since there's 4 here and there's 2 here, so I can get rid of that 2 and just make that a 2. So yeah, not really sure why I didn't do that. And then what did I give myself a mark here for? Correct balancing? I guess that's correct balancing, so yeah, so I knocked the product for correct. I didn't get the correct product and reactants because I had H2SO4 as a reactant, but I suppose I got correct balancing, so balancing follow through mark. Balancing follow through mark. That must have been what I was thinking. I've been marking this over like an hour. It's been taking me so long. And then this was all good. Yeah, you didn't need explanations for this. You could have just done what I did. And then yeah, that's pretty much what I got. You could have also said, you could have maybe explained high cost, but again, in the notes it says no explanation needed. Going down. I lost 5 marks here. No, sorry, I didn't lose 5 marks. I got 5 marks and I lost 1. Because you needed to say with excess, that was specifically, there's literally a bracket 1 next to excess of a nitrate solution. I assume you could have done any nitrate solution. Not sure though. And then everything else is correct. They said filter off, precipitate, then wash, but I said evaporate all the solution away. So for step 2, instead of this part, so I think they're equivalent because they do the same thing. Maybe I could have said evaporate and wash. Maybe I shouldn't give myself the mark there. Try precipitate. Evaporate all the solution away, filter and wash. Yeah, I feel like wash might be an important step. Maybe I'll knock off another mark. And wash. So that will be 95. This will be 97. Hopefully it doesn't change my mark too much. .4. Okay, where were we? Scroll down a bit. Yeah, I think washing is probably an important step. But yeah, drying, precipitate, weighing, and then all of that. This next one I got, so I just adjust this here, 4 marks. Here I got 4 marks, going down. 4 marks, except for, again, I didn't talk about maintaining electrical neutrality. Oh my god. But for some, it's worded weirdly. A salt bridge is required in a galvanic cell to maintain electrical neutrality. So I guess because they are not, they're separate half cells, I guess. Maintain electrical neutrality in a galvanic cell. And here, this wasn't specifically, it was kind of conjoined with what I said about the electrolytic cell not having separate half cells, it's just one. It said because the reaction is not spontaneous. So, but I had like most of the mark, so I gave myself 2 marks there, so 6 marks. Here you needed to have, I only talked about, so I talked about this, it's toxic or whatever, and then I talked about how maintaining like a basic environment ensures there's a minimal potential for it to contact the acid or H+. But then you needed to talk about like something extra. So some of the possible ones are without H+, the HCN does not form in significant concentrations, significantly dangerous concentrations. Oh, you could have had the equation, but I didn't have any, so only 2 marks there. And that's got 3 marks there for safety. Got the pH question right. All of these reactions of, oh yeah, here it says butanoate ion. I wasn't sure if I should knock off a mark because I got butanoate. If you search up butanoate in Google, it comes up with this, so I'm not sure. If I'm to mark the marking key, they should have said anion, so, but you know, it is what it is. I gave myself the mark there. Oh yeah, you could have also done Na+, and then you could have said sodium butanoate. I think I was discussing that if I should have it or not, and you definitely can, but it's not necessary. And then continuing down, 4 marks there. Here I lost 2 marks because I needed to say that the rate of CO2 produced is a measure of the reaction rate, which I was kind of hinting towards, but I didn't explicitly say. And then you also needed to say that the surface area of magnesium carbonate decreased, then reaction rate would decrease. And here, I didn't knock myself a mark off for this, but just in my discussion and like talking about it, completion of limiting reactant, I know you can figure out which is limiting reactant because it says there's excess nitric acid. So then your limiting reactant only can be magnesium carbonate. So 2 marks off there. And then the line, you just had to draw it a steeper gradient and it achieving the equilibrium faster. So I had it achieving about there, which is faster. And then, let's see. This, it was sulfurous acid, and I only had one explanation. My equivalence point thingamajiggy was correct. You could have also said that the H2SO4 and H would be less than 1. Or you could have said that since H2SO4 is a strong acid, it would only have one endpoint and one plateau. So 2 marks there. Here my systematic error on titrations was correct. And then classified as systematic errors was also correct. I could have said more specifically consistently above or below actual value, but I said consistent effect on data, which I think is close enough. If you just said errors will occur every trial, you did not get a mark. You had to say that it affects the titration consistently. So 5 more there. On to section 3. For this, you could have just labeled them like this. And also, you didn't need to say that this was the conjugate acid, and you didn't need to say, you could have just said that was the acid, and that was the base. Which is the base nature pairing. So yeah, 2 marks there. This was all fine. I actually did quite well from here onwards. Oh yeah, I think it was these. Yeah, question 36, E, F, and G do not have actual answers in the marking key. So I was just discussing on the WACE Dungeon Discord, and then there was someone that sent like a mock marking key, which we all agreed on pretty much. Well, not we all agreed on, but you know, we all were kind of using. So I used that one. And then this one was fine. Alcohol, hydroxyl. I think you could have also said hydroxy. Yeah, you could have said hydroxy. And then for this, you could have said carboxyl. So that's just 2 different alternative answers. Going down here, my diagram was actually correct. I'm usually not so good at diagrams. You just had to show an ion-dipole interaction and then dispersion-dispersion interaction. My explanation was correct. I just needed to talk about that the ion-dipole attractive forces of water between the charged head and water are stronger than the water-water bonds, or the hydrogen bonding between water molecules. So they will dissolve in water, or the soap will dissolve in water. So overcoming between dissolves preferentially in water. Everything else though was correct. And then here I just needed to talk about, I could have maybe said insoluble precipitates, but precipitates kind of implies that it's insoluble, so I gave myself the mark there. And for this, soaps apparently have a carbon chain of greater than 12. So I thought 8, because in Pearson it says fatty acids, triglycerides are made from fatty acids, and fatty acids are carbon chains of 8 or greater. And then since you get soaps from those triglycerides, when you break the ester bonds, you're essentially left with a fatty acid left, so I thought it would be 8 or above, but apparently it's 12, so I knocked the mark there. And then continuing down, soap ions, I was correct. I think there's an error in the marking key, because they have 18 carbons, so they ended up needing 2 double bonds. That would have been something like this, C, boom, and then they just move a H or whatever. So they have 18 carbons, which obviously is not correct. And then for this one, it was good. I think you could have done the ionic again, so you didn't need the Na ion. But this one explicitly says no mark penalty for using molecular versions of KOH or NaOH. So yeah. Here I lost 3 marks. Because first mark I lost was that I said reactants in general. And I think it said that, yeah, oil grease does not have a concentration, so should not be referred to because they are liquids, I think. So I only needed to talk about NaOH. So I lost a mark there. I lost a mark here because I didn't talk about how yield will increase when you have increased concentrations of NaOH. I'm not sure if this explanation actually makes sense to me. I guess if you mean overall yield, it's fine, but like fold reaction gradient and reverse reaction, sure, that's true, but it's not going to increase your yield, I think. It's just going to get your yield faster. So I'm not sure if that explanation is totally correct, but I didn't talk about yield. Also, as amount of yield increase, okay, well that's just wrong. This one I meant to say like reactants. I mean, because that doesn't even make sense. Anyway, and then I lost another one because you needed to talk about agitation or removal of product, because agitating it will increase the surface area, so then there's more collisions, and removing them will minimize the reverse reaction, so you increase your yield. So 3 marks lost there. Yeah, my choice and justification were fine. You didn't get any marks for your choice of polymer. You only got the marks, 1 or 2 marks, for your justifications per use. Going down. This was so close. I think you got. Let's see. So you got 1 for the methanol structure, which I got right. You got 1 for the carboxylic acid structure, which I nearly got right. It's just that when I added that double bond, I didn't get rid of that hydrogen. But otherwise, my structure of the ester and balancing was correct. Balancing because you needed water. Here, this was good. Going down. The assumption was correct. Good thing I didn't talk about it equals 2. And then 1.93 times 10 to the 6 grams. Going down, so that's 5 marks, yes. Yeah, I gave myself 0 marks. Because even though I was very close, I probably could have I didn't talk about the monomers at all. I just said the breaking of alkene bonds. Like, okay, alkene bonds of what? So I should have said of a single monomer. And then the mark key goes a bit step further and says across which 2 species are added. And then for the condensation, again, I could have said 2 monomers because 2 reactive functional groups reacting is like, oh, okay. So definitely talk about monomers. And then hydrogen chloride is a byproduct, so it's classified as a condensation. So yeah, I said here therefore condensation, and then here therefore addition. Come on, addition. So yeah, marking key word for word verbatim is polymethyl methacrylate is produced from one type of monomer that contains a double bond across which 2 species are added. And then polycarbonate is produced from monomers with 2 different reactive functional groups. And the hydrogen chloride is a byproduct. So yeah, I just got to talk about the monomers there. Especially of the addition one, where I got to get the new wording, which 2 species are added across. So yeah. And then monomer. I got the average titer correct. I got the solutions correct. You had to talk about concentrated and diluted, I think. The herbicide. No, actually, for this one you didn't need to talk about that. But for the second one, you did need to talk about diluted herbicide. Distilled. You could have also said here deionized water. Moving down, 276 grams per liter. You got up to 6 marks for this, and then 2 marks They did. Calculated. So what they did was they found the range from the 5%, but I found how far percentage away it was from the advertised, and then I justified no, it does not match a given label. So I gave myself the full 2 marks there, even though they did a different method, but we ended up getting to the same answer. Because I mean, like, you can do it either way, and it shows the same thing, that it's outside of the 5%. So I gave myself the full 8 marks for that question, so 11 marks in total for that page. Here, I was surprised that I didn't lose more marks for sig figs, because I think throughout the exam I wasn't thinking of them at all. But yeah, appropriate number of significant figures. It was only 2 for this question. I gave it to 3, so I knocked the mark off. Otherwise, it was all correct. Here, I must have been racing for time because I missed that it was K2SO4. So the number of K plus ions would be double. So I got the question wrong, but I gave myself, there was a mark awarded for that from A. And then there was a mark for the number of K2SO4 added, and then the mark for K plus added, so I lost both of them because I didn't do those properly. But I gave myself a follow-through mark for saying it was not sufficient, when in reality it would be sufficient enough. But follow-through marks are 2 marks. Down here, the overall balance equation was correct. This was also correct. 82.4% yield. And then scrolling down, this was correct. Just looking at the data sheet, bit of a boring question. Peptide bond. This is getting ridiculous. So another type of peptide bond we can have is the CO, and just like that. So let's list the ones we've seen. We've seen that one. We've seen that one. We've seen that one. And now we've seen that one. So that's 4 different ways you can circle peptide bonds. Here, what is the difference between primary structure group and secondary? Primary structure, Mark and Key said the sequence of alpha amino acids. But I said the type and order of amino acids, which, I mean, type and order is pretty much the same as the sequence, which is fine. And then for secondary, there's 3 possible ways you could have answered. You could have said how the amide and carbonyl groups in a protein chain interact to form alpha helices and beta pleated sheets. Or you could have said secondary structure results from interactions to hydrogen bonding between amide and carboxyl groups. Or you could have said interactions in a protein chain to form alpha helixes and beta pleated sheets. I said they form alpha helixes or beta pleated sheets through the hydrogen bonds. So I gave myself the full 2 marks there. And again, I gave myself the primary structure mark. And then the very last question here, guys. I thought my diagram was an appropriately labeled diagram that shows interactions within and or between molecules of polar carbon compounds and water. So I said this was a polar carbon compound, and it shows interactions. So I gave myself the mark from that diagram, and I thought I wouldn't get it. And I actually got most of the marks here. The only mark I didn't get was that the protein intermolecular forces increase because of the increasing dispersion forces, because the proteins are large. I just said held together by stronger EMF in general, so I thought that wasn't close enough to the marking key, so I knocked myself a mark there. But other than that, I think I pretty much got everything correct. There was one thing I wasn't quite sure about. Mark and Key says the sum of force of attraction. Here they also said H bonding for forces between water and polar carbon compounds. Now I'm not sure if polar carbon compounds, if they are like all possible to create hydrogen bonds. because they definitely are capable of dipole-dipole, but I would assume that not all of them are always capable of forming hydrogen bonds. So I wasn't sure if I needed to add that, but the marking key does say it. And that's a kind of gripe I have with the marking key. That I'm not sure if that's like a thing, where just because something is polar, something can be polar, but not polar enough to have hydrogen bonds. Which is why I didn't have hydrogen bonds. So I don't know. So I gave myself the 5. I only knocked the 1 mark for the protein thingamajiggy. So yeah, that was the end. We got the 93.4% because we found a mark I gave myself that we shouldn't have actually. So yeah, I'm actually really happy with that. Hopefully, if I get this in WACE, I'll be over the moon. I think my average in chemistry right now is a 93. So yeah, this would be, it won't boost my mark at all, but it will keep it right at 93. So then hopefully when I get scaled to hell, because we all know that's going to happen, scaling is terrible, that hopefully it keeps it up a little bit higher. So yeah, that'll be it for today. And then I'll probably do another chemistry. I think because my exam is a 26 right now, and I have my chemistry exam on the 31st. So 1, 2, 3, 4, 5, at least 5 days, including today, to do exams until then. And I still have 2020, 21, 21, 22, 23 to do, so that's 4. So I think I'll do 2 chemistry exams over the weekend. Or maybe, I don't know, I'll see how I fit in. And then I'll do 1 physics exam in the middle. And then I'll do 2 more chemistry exams leading up to the days before my exam. So yep, that's it. See you.